So, hello everybody. Welcome to our today's webinar for Ethernet IP for our Dunkermotoren motors. Welcome to you, and I am happy that you join us here in this webinar, and I hope we can give you an interesting half an hour and some good inputs and informations. If you have any questions, just as an information up front, place them in the chat. We will have a look at them and we'll answer them in the end of the webinar. And I think so we can get a smooth webinar and can also answer all your questions. So who is doing the webinar today? So on the one hand, it's me. It's Markus Weiser. I'm here head of systems and services. I'm responsible for supporting, programming, and the operation of our motors and giving service and help customers in the field. And next to me, it's Alexander Haberstro here in the call. He will introduce himself later on when he has his practical session. What will be the agenda for today? We will start with a short introduction from me, what's behind our Ethernet IP interface for the D-Pro motors. Then we will go through a live demo of Alexander, how to integrate a Dunkermotor to a Rockwell PLC. And in the end of the webinar, we will give you an outlook what comes next in the area of Ethernet IP. So first of all, who should use Ethernet IP or why should you use Ethernet IP? Of course, the most common intention is if you want to connect the Dunkermotor to a Rockwell PLC, then it's logical to use Ethernet IP with the basic protocol of Rockwell, and which is the ecosystem for these PLCs. But also, next to Rockwell, some other PLC vendors also set on Ethernet IP as an ecosystem. So you also, if you want to introduce a Dunkermotor in general in an Ethernet IP ecosystem, it's also an intention to go for it. And the last one, Ethernet IP is close to the IEEE Ethernet specification and sets there on top. So it's close to the basic or the common Ethernet. And so if you want to use an Ethernet close to or a field bus close to the Ethernet because you want to do something else on it than just transferring field data, then Ethernet IP is a good choice and can give you a good benefit there because it's also easy to communicate without a master or with different devices. Then I want to introduce you shortly our actual available basic package that is available since this year that fits perfectly in our motion control platform as one extension in the direction of connectivity. You see it here in the upper right left corner. There it will fit next to the other interfaces. And what is possible with this basic package? You can set the IP addresses of Ethernet IP via boot P and DHCP, what is common. And we have implemented the addressed conflict detection that tells you if there is a double IP address, for example, in the system. You can integrate the device easily in the Rockwell PLC via an EDS file. You can possibly go down to cycle times of down to 1 milliseconds. You can control the motor via our common Quickstart command, so that makes it easy. If you also use another motors from us with other protocols like an Open Motors, Profinet or EtherCAT motors, so there's the same logic behind and you can control the motors over all the protocols in the same way. The diagnostic of the motor is given via providing of status information of the motors to the PLC, and of course you have access to all the motor parameters that are available. You can read and write them. And here at the last point in the introduction, give you an overview where Ethernet IP will be available. Ethernet IP is available over all our new motor generations, all about the D-Pro motors, from the big BG95 in the background of me which supports 4,000 watts or nearly 4,000 watts, down to the small BG motors, BG32, supported by the BGE 5510. So overall, our BG MCP portfolio Ethernet IP is available. From this point, I want to hand over to Alex. I'm done with my short introduction for Ethernet IP and how our actual package look alike. And now I think the interesting part of the webinar starts and we have demo time.
Yeah, thank you, Markus. My name is Alex Haberstroh. I'm here at Dunkermotoren since now over 3 years as an application service engineer. If you have any problems with our motor while commissioning or just have questions about commissioning, then the chance is quite good that you will get in contact with me. Today I want to show you how to integrate our motor into the Rockwell PLC, and therefore my commissioning setup looks like this. I have installed on my PC the Studio 5000 software as well as BootP, and also our drive assistant runs on it. And I have connected it to a Rockwell Compact Logics PLC. And of course, the most important one, our motor, the BG95D Pro Ethernet IP. And all components are connected via an Ethernet switch together. If you get an Ethernet IP motor from us, you will get a so-called starter package or starter kit. It looks like this. There included is anything you need to run it. For example, the EDS file and also the parameter description, some IOIs we will talk about later. And most important, the Let's Connect, which is a short instruction on how to include the motor into Studio 5000. If you have a short look into it, we see here some general stuff and the LED description, and then followed directly by step-by-step description how to install it in Studio 5000. Of course, the first step is to install the EDS file. I have done this already on my PC, so I will skip the first step, but I think anybody will know what is meant by it. In the next step, we will have to set up the IP addresses. Therefore, I will use BootP. I will have started it already in the background that we already see the devices which are asking for IP addresses. And here we have beginning with the E4, this is our motor, and beginning with the 5C is the PLC. And if I add here a relation, I can give the IP address. For the PLC. And also for the motor. I think anybody who uses Ethernet IP should know this tool. Of course, it's possible to store the IP addresses with this tool into the motor. How you know it with a disable BootP button. It's also possible to store the IP address with our drive assistant, and it's also possible to give it with the with an DHCP server. Okay, so let's go to the next step. Now we see here that the motor already has its IP address. I think the PLC will follow soon in a few seconds. And until then, we can go on. If we open Studio 5000, I have here created an empty project and just connected to my PLC. I didn't do anything else. And Now I can search here on the Ethernet port for modules, and the window opens. It's searching for the modules. I hope this did work. Let's try it again. Anything connected? Okay, now we find the motor. We see here the IP address. We already see a little picture of it, and we can create it here. I just will give it the name drive. Yes, I want to do it online. And now the motor is created, and that's it. Now I'm able to run the motor with my PLC. If I go into the controller tags, I see here the input data of the drive, 8 byte, 4 byte, and output data 10 byte. And in the future, here will be clear names of the objects behind. Right now, we are waiting for Rockwell to declare our EDS file as good, and then the clear names will be here. For the moment, I have in the Let's Connect a picture created which describes which byte means what. So we see here the 4 byte input data are the device status register, and the 8 byte 10 byte output data are the 3 Quickstart command parameters: command data 0, command data 1, and the command itself. Let's have a look what Quickstart means. If I go into the parameter description out of our starter package, we can find here also some samples, but I will go straight to the parameter description. And if I have a look into the command, we see here at the top the most important ones like quick stop, start motor in the different device modes, start homing, and so on. But there's much more possible. The idea behind quick start is to be able with just these 3 parameters to do as much as possible with the motor without any additional parameters in the cyclic data. What we want to do is we want to run the motor in velocity mode. So this one, start motor and profile velocity mode. Therefore, we want to use the command 121. And if we have a look into the desired values, we can see here a table to which command, which parameter of the desired values means what. So in our case, for the velocity mode, Quickstart desired value 0 is used as desired velocity. For example, for the positioning, the desired value 0 is used as desired velocity, and the desired value 1 always is used as position. Okay, so if we go back to Studio 5000, and I write here, for example, 100 into desired value 0, and then here the 121 for the command to drive. But I think maybe there could be an error on the motor, I don't know, so I will send a clear error command first. It's just a 1, and then the 121 afterwards. And now the motor is already running. I think you can't hear it, so I will show you. Therefore, I open the Drive Assistant 5. It will take a little moment. And for anybody who knows our Drive Assistant, it's quite simple. You can use it parallel to the EthernetIP bus. And if you select the right connection, you are connected to the motor, and you can see here that I'm running with 100 RPM right now. The position is changing and so on. It would be also possible to read back here my Quickstart command. So if I enable the reading, I see Quickstart command data 0 is the 100 and the command itself is the 121. So that's it. It's quite easy to import the motor into a Studio 5000 project and get it to run. And of course, that's not anything what is possible, because there are a lot of other parameters. For example, if we want to read back the actual velocity now, this is also possible. So if we want to read the parameter velocity, actual velocity, therefore we can use the acyclic data. That's quite easy. So if I go in my main routine, I can add here 2 instructions. And the second one, if I use the message instruction, this one is used to speak acyclic messages with the motor. I have to create an instance, therefore. And if I have created it, I can go here into the message itself, and there I can create choose the service type with get attribute single. I can read any parameter of the motor, and with set attribute single, I can write any parameter of the motor. In our example, I want to read the velocity, so I choose get attribute single. Then I need to fill in the class, instance, and attribute. I can find them in the knowledge base. So I see here class 304, instance 1, and attribute 30 in hex. And the name is velocity, actual velocity. Also important is the data type, int 32. So let's go back here, class 304, instance 1, attribute 30. Let's just double check. Yeah, it's okay. And then I just have to create a tag where the value should be written. Therefore, I paste the name of the parameter. Here I have to choose the correct data type. In my case, it's already fine. Int 32 is double int in Studio 5000. So I just create it and then I choose it here. In the next step, I have to choose the part of the machine which should be talked in this message block. So here I choose, of course, the motor. And that's it. I have created here a little block to toggle. So just for the easier control, read velocity, I will create a tag. And now I accept the program edits and activate them. And now if I toggle this bit, my message block is executed, and like you see here, it's done. So if I go in my parameters, I can see here the actual velocity. And with this one, I can always, with a positive edge, it's red again. So this time it was 99, and so on and so on. Of course, you are now able to read the parameter as often as you need it. And to write the parameter, it's exactly the same procedure. You just have to choose set attribute single instead of get attribute single. So it's quite easy, and you can access all parameters of the motor. Okay, so that's the demo of the basic package, and I will give the word back to Markus.
So thanks, Alex, for the interesting and easy demonstration of how fast and easy it is to introduce a motor to a Rockwell PLC with EthernetIP. And I think now everyone in the webinar is also interested what's maybe next. So now we have a running Ethernet IP integration, but we now work at the usability, so to make it even more easier to use than it is already now. So therefore, we are developing standardized AOIs, means add-on instruction. That's blocks that can be directly used in the PLC code of Rockwell and define standard commandos like homing or positioning of the motor or clear fault. And that is what we are working on just now. Alex also will give you a teaser later where we are here in the development and how this could look like. Then, of course, we have the ODVA certification on the plan. We will do soon to have certified motors that are able to be integrated in every Ethernet IP environment without problems. And to be honest, what comes then as a next step, I think we are unsure until now. It could be SIP safety, it could be SIP sync, it could be SIP motion as extensions of Ethernet IP, but that's your turn. I think here we are really request your feedbacks, your demands, where the development of us should go in the future. What are the features you need most? And therefore we will go as the next steps. That's the point you can expect from the Ethernet IP developments from us within the next months. And therefore, let's go with the teasers for the EOIs and again, demo time with Alex.
Thank you, Markus. I just created a little demo project, therefore, so I will close this file now and open the other one. We have created a few of them, and there will follow a far more in the near future. So if you have any ideas, therefore, just let us know. Maybe we can implement them. And our aim was to be as close as possible to the AOIs of the common or of other drives you maybe already know on Ethernet IP. So if you already have an Ethernet IP motor running, in the future it should be quite easy to change to our motor because the AOIs will be working like it's common on Ethernet IP buses. So now my project is open. I will download it just to my PLC. It will take a second. And meanwhile, I will talk about the AOIs. Until now, I have implemented two in my project here. You can just import them like any add-on instruction by right-click here on add-on instructions and then import. It's quite easy. I have imported two of them. It's the motion axis fault reset and its motion axis move. The motion axis fault reset is used to reset any error on the motor. And the other one, the motion axis move, is used to run a positioning on the motor. If we have a look in my main routine, I have set up here the same like we did together with the read velocity, and then two more. Here I have the motion axis fault reset block. This one is used to reset an error, and here I have the motion axis move block, and I can enable and disable them by my two commands here in front of them. Right now, I think we should have an error. Yeah, we see here in the drive assistant, the motor has an error -501. It's a communication error. This is because we downloaded a new software to the PLC and the connection was lost for a short time. And our motor did detect this and did stop running, that it's not uncontrolled running somewhere. And with this, I can enable our block here. like you see here, it's just the block itself. Then you have to choose which motor you want to talk with this block, and the same down here. And if I enable it, the error is cleared. I can see it here, the error is cleared. And in the next step, if I want to run a positioning, here it's the same. I have to choose the motor. Then I have to set up the target position. I have created a tag, therefore, where a 0 is right now. And I have to give it the target speed, 2000 in my example. If you have a look in the motor, right now it's on position 2020, I don't know, 290,000 or something, or running with the velocity from before. And if I now execute this AOI, then it's running backwards with the velocity 2000 to the position 0. I'm not sure if you can hear it. And you see here, right now, it gives back the in-process bit because the positioning is running. And when it will reach its position 0, then the process clear bit comes right now. And this means that the position is reached. We can double check here. Yes, it's position 0 right now. And the positioning did work. So it's quite easy with this AOIs to control our motor. And yeah, I think that's it. A few more will follow. And if you have any idea about them, just write us. Maybe we can implement them. Right now we are working on it. And of course, any feedback is always warmly welcome. Yeah, I think that's it from the second demo part. And I will give the word back to Markus.
So thanks again for Alex for the second demo. I hope we was able to give you a good idea what's capable with EthernetIP on Dunkermotoren, and you feel welcome with what you have seen. So finally, we can say as the statement of today that our D Pro motors are ready to use with EthernetIP, or you can just start to integrate them in your EthernetIP networks. So thanks again from my side. And are there any questions from the round? So if not, thanks a lot for your attention during the half hour, and we hope it was an interesting webinar for you, and we hope to see you soon using our EthernetIP motors. Thanks again and have a good afternoon.
Thank you. Bye.